Okay, I think we'll get started. So welcome to the first part of machine learning and general chemistry. And here we are going to lay down some of the foundation, very simple foundation for machine learning. I am certainly not an expert, but I am 100%, I 100% believe that it is imperative if you're an aspiring chemist or if you're a chemistry professor that we need to get machine learning into the chemistry curriculum. So it is becoming a very, very useful tool. Now, when I say machine learning, I'm not talking about AI altogether. I'm talking about the very specific area of machine learning, in particular regression models and image recognition models. So the very specifics of looking at large chemical data sets. In the world of AI, that's a different story. So large language models, generative models, when these come together as agents, that's going to radically change everything. All fields will be impacted, including chemistry. And I think that's also very important to get yourself situated so that you can really ride this wave of AI to help you become a better chemist. But that's not the focus of this work here. All right. So against my better judgment, I am going to gear this for three audiences. The G. Lewis Project. So if you've looked at some of those and worked through some of those, this will be fairly consistent with the way that's done there. If you're a Concordia student, so the college that we're at here, then hopefully this can lend some support. But I think you'll want to also be connected with your actual instructor on how to go through this. And then finally, if you're a high school teacher or a college professor in chemistry looking to introduce this into your curriculum, then I think that hopefully you can gain some ideas here. Use it directly or come up with your own ideas. All right. Well, I'm going to just say a little bit about myself. I'm Darren Olness. I'm a professor of chemistry in the chemistry department at Concordia College and also in the neuroscience program. Over the years, I've taught physical chemistry, general chemistry. Right now I'm teaching physical chemistry and physics primarily, but offering some courses in advanced math and in neuroscience. And I have set up this G. Lewis project, and I live my professional life very much guided by this famous equation, or this famous quotation by G. Lewis, a famous chemist. It says, "Physical chemistry is everything that's interesting." And I think this can be read in two ways. One in a narrow-minded view, in which the only thing that's interesting is physical chemistry. But I read it entirely differently in a very open point of view, and that is that learning physical chemistry gives you the foundation to study anything that you find interesting. It is a deep and systematic way to look at nature and understand nature regardless of whether it's traditional physical chemistry. And so this has allowed me to have just a wonderful time learning various different subjects, including machine learning. And so there's a lot of cool stuff in machine learning that I find very interesting. Okay, well, let's get to the nuts and bolts then. So this is only 4 labs. The labs are pretty quick, so you want to get it all done right away. You could, I think, get this all done in a week. First lab is dealing with jargon. So it's not even a real machine learning lab. We're going to look at look at the stuff for these labs that we would use to evaluate a machine learning model. Then the lab 2 is going to focus on predicting properties due to the relationship among those properties. So machine learning is good at finding mathematical relationships between properties. And then the last 2 labs is going to focus on image recognition, both using convolutional neural networks. The first one is going to mimic a situation in quality control chemistry, and the last one is going to mimic surface crystallography and surface reaction dynamics. Okay, let's get to the setting this up. I do want to say one important thing. There are a couple of changes that will probably be happening even if I don't change these videos. And most importantly, the way, and I know this is getting ahead of things, but the way that residuals are presented in the programs here are not consistent with the first one. So I'm going to try to change those programs. So hopefully the one you're using will have a more consistent message throughout all of the labs. But what you're about to see in these 4 videos, unless I change the videos and add make new videos, will be the current version of the program. But hopefully that's being updated, and when you're watching this, it is ready to go in a more consistent manner. So I just warn you of that ahead of time. All right, let's go in pretty easy to straightforward to get this set up, but I'll walk you through it. Okay, so let's go to our installation guide, and I'll show you where we can get that. So the first thing you're going to want to do is go to Google and just type my name. And it may, I suppose, depending on where you are in the world, hopefully it'll show up early on. And so if you go to darrenolness.com, but you could just type darrenolness.com in your browser. So we'll do that. And then under teaching, you can go to, you can either go to machine learning, just scroll down to machine learning here, or you can click on teaching, go to the teaching page, and go to machine learning for undergraduate chemistry. Now, so this is going to be the landing pad for most of the stuff that we deal with in terms of machine learning throughout the curriculum. But right now we're focusing on general chemistry in the G.N. Lewis project, and so if you'll find that here, and that's all that's here right now. But maybe when you're looking at this, there'll be more stuff up here. So a little bit about the project up here, but let's scroll down here to the Get Started, and you'll download the Chem AI history, or Chem AI history. It's hard to say, but I think it's a clever name that my colleague in the chemistry department in our chemistry department came up with. And so let's get the Chem AI history 1, so that's referring to part 1, Explorer Pack. So this will have all the programs, and it will have the data that we'll be looking at as well. So let's go ahead and get that. So you should see it here. You can hit download. I'm not going to hit download. I already downloaded it. So you can hit download. It's sitting here in my downloads. So go ahead and do that. While that's downloading for you, I can show you that we have a setup guide here. That's what I have here. So go ahead and click on that. And that's exactly what you're seeing here, or an updated version. But I'll go through this. Okay. So let me just kind of go through this back and forth. So here, I think the only thing of real importance here is right now it's only Windows. So I'm trying to, I don't have a Mac, so it's harder for me to create freestanding programs, executables for Mac as it is for Windows. But I'll try to get a Mac and a Linux version as well in the future. And then this is embarrassing, but it is 5 gigabytes of space you'll need. So it's not completely embarrassing because 3.5 gigabytes of this is the training set data. So on one of the labs, we need extensive training, and it won't work for you to do it during the lab. So these are pre-trained models. The biggest one of those took my computer running full 100% CPU, almost all the RAM, for 14.5 hours to generate the .keras files for one of the particular labs, the third lab. So 3.5 gigabytes of this is pre-trained, but still I am no computer science expert, so I guess I do what many other people do, take advantage of all that space we have and not try to write the most tight programs. So still need a lot of space on your machine. Okay, we're at this page here. We're downloading this pack. So let's go ahead and see where that is. Hopefully that's downloaded for you now, and you've downloaded this setup guide here. Okay, so I will go now to the Explorer pack, and I have made in my C directory, I've made a temp, completely empty. That's where I'm going to put this now. I have it installed in my program files, but so I don't want to overwrite that or anything. So I'm just going to put this into temp so you can follow through. One, I'll say this at the end. If you put it in program files, it's kind of nice because it's in your program files, but there's going to be a problem with it that we'll have to overcome, and I'll talk about that. I think it'll probably work in the temp, so it'll be good to see if that actually does so. So where was I? Okay, so we'll go to downloads, and now let's extract. So we'll extract all, and let's browse to C temp or wherever you would like to put it. Okay, and we will extract. So this could take some time. If it looks like it is, which it does look like it is, I will pause this video and then pick up when it is done. Okay, so this has now expanded into this directory. So we should see the manual, the installation guide, and the installer, and then the data sets. So these should all be just regular directories now, and we should see the various data sets for all 4 labs. So we should have 4 subfolders in data sets, and these will be where you'll go when you're running these programs to pick up your data. So now we will do the ChemAI installer. This will install in a normal way. So I'll go ahead and do this. Once it gets going, we'll see how fast it's going. I might pause. Oh, and let me first open the manual. So there'll be some changes to this manual, but at least it can get you going. And if you follow along, I'll mention a few things. So if you follow along, if you're a student, either from the G.N. Lewis Project or Concordia College, you can just follow the black. And then I've added in red some instructor notes. And this occurs, there's a page here before the lab start. And then in any given lab here, so here's lab number 1. And I've put in red again some instructor highlights. So you can just skip these or look at them if you're a student. But if you're an instructor trying to look at how you might use this in your class, then you can look at these red things in the manual. All right, so that's the manual. And you can find the manual right here on our webpage as well. But let's go back to the installer. So this will install like a normal Windows program. Hopefully. Okay. I'll put it into temp, and I'll just install. So I'm going to pause. So it looks like we're almost fully installed here. Okay. So now we should see just one more file in here, ChemAI-1. So this is the launch program for this. So when you go into the lab, if you're starting right away when I upload this, the manuals will refer to the individual programs. Here, all we need to do is start one program, and you'll notice the terminal come up. This is just something I could never figure out. For some of the programs, we have to have this Windows terminal running in the background. So you can't close this, but you can minimize it and just put it down. So let's look around here a little bit. So each one of these buttons are the 4 labs. So this is lab 1. It's kind of out of order here. This is lab 1, lab 2, lab 3, lab 4. And then down here are some additional buttons. So let's check those. This will go to the repo. So if you want the Python files and to adjust them for your class or your use, then go right ahead and do that. The chemistry department at Concordia. So I'm working in I work in the chemistry department, so I'm merging the G and Lewis project here and some of the stuff we need for the chemistry department there. So you can find that there. And then let's see. Let's look at the course webpage. So this will just take you to the course webpage if you need to get there quickly. So that's a good launch pad here. Now these should launch each of the programs. So let's go ahead and try these. I don't think I'll try every single one. I want to try this one because that can cause a problem. So first I'm going to just try this one. And what you'll notice is it should open on a single click. And the first time it goes, I think it's a little slow here. Okay, it's open. So this is open. This is a quick test you can do. So open this first one, this one that's up in here, basic residue. Do a load CSV, find your data sets, basic residue, and then just pick one of these and make sure it comes up. So that means that works. And you could do that for each one of these. So I'm not going to do that, but let's do this one because this can cause a problem. If it doesn't cause a problem, which I don't think it will here, then I'll tell you about when it does. So let's open this up. This is one of those programs where it too has to have the Windows terminal, and likely a bunch of nonsense will come up here, but you can just keep that up. Okay, so let's go ahead and load a model. Go to data sets. Now this one is the PEM sorter, and so let's choose it doesn't matter which one of these you choose. So let's choose this, and then you'll have to choose this pickle file. It'll say loaded. When you do this, it should work. Okay. Now when you do this, either it will work or it'll crash right away. So let's try it. In a sense, hopefully it crashes. Oh no, it works. Okay. So it does work. So when it crashes when you install this in a directory that needs permissions to install. So program files, if you wanted to put it there, usually requires you to give permission for the program, for a file to be written in that directory. If that's the case, let me direct you to this last page in the troubleshooting. What you need to do is go to where this is, and notice these folders are created. Now I think down the line when I make a change to this program, I won't dump the files. What these are doing is they're dumping images that you can look at later. These specific folders, acceptable large, acceptable small, pure large, pure small, and reject, all need to be in the main directory that ChemAI-S3 is in for it to work if it needs permission. So here it didn't need permission, it could just write it because it's just this random directory. But if it's in a directory that you have that is set so that it requires permissions, then you'll have to go in and make these so that it can find these. Once you do that, then it should work just fine. Okay. All right, so I think that is it. So I think we will sure what else here. Again, this is Creative Commons, so just you want to use it while you can. That's totally fine. And if you have a good idea and or ways to improve this. If you're an instructor or if you're a student and you just found something confusing, please reach out, let me know, and hopefully you can try to make this better, because it is something I think that will be really important to the undergraduate curriculum. Okay, well, that's it for the introductory sequence. Hope to see you in the first lab, and we'll get going studying machine learning and chemistry.